Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. This session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a certified Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you. I'll just quickly share my screen. Okay, so first of all, good evening to everyone. Hopefully you all are at home, you are safe, you're doing well. My voice is a little off today, so I hope it gets warmed up. Now we will get started with this session, and we are talking about data lake, delta lake, and lakehouse architectures. So we'll see what are the benefits of them, and we'll go through the various concepts as such over there. And then once we have done all of that, we will go through the demo as well. So we have 1 hour with us. So we please put your questions in the chat window. I have the chat open with me on the secondary screen. I'll see if I can take all your questions on the way, right? So let's get started. Now, before I start, I just want to put some context and some background as well. And if you have joined me for the previous sessions, I used a lot of whiteboard, right? So let's go through it. Now, first of all, we will start from data lake itself. We'll understand why data lakes are there. What do we do with data lakes and how do we, and in Azure, what do we do with it, right? So basically, if you are familiar with core Hadoop ecosystem, you know that HDFS is the storage layer where the big data is stored itself. Now, HDFS is distributed in nature. On top of it, we have Yarn. Yarn is the resource negotiator. Then on top of it, MapReduce comes as such. And if you are aware, this is the Hadoop ecosystem. If I create one box over here, right, like this. So this is the component of Hadoop ecosystem. Now, let me just put big data ecosystem on the top. Like this. Okay, so the very first thing we want to understand is where is data lake going in the big data ecosystem? So if I just put it forward, Azure Data Lake is 100% compatible with HDFS, and this is where it goes, ADLS Gen 2. So you are already aware that Gen 1 is getting deprecated, right? You cannot create new Gen 1, so Gen 2 is the one which we use. So if you think in terms of data lakes, then in the big ecosystem, the ADLS Gen 2 is replacing HDFS in the cloud. Now, why do we do that? What are the features of ADLS? Or what are the features of any data lake? Please put yourself on mute, right? So what are the features of any data lake as such? What is the feature of Azure Data Lake Storage, and what are we going to do with that? So let's move into that direction. So if I just try to represent that data lake over here, right? So when we make the data lakes in Azure, it is built on top of object storage. So the backend is the reliable and cost-effective object storage, and it has no limits. As such, you can put any amount of data in data lakes. Apart from that, this also is providing multiple tiers of data. You can have hot tier, you can have cool tier of data, cool or cold, or you can also have archival tier over there. So that provides multiple functionalities where you can create a life cycle of your data as well. You can move your data from hot to cool, and you can get discounts based on that. Now, apart from that, so if I just put hot, cool, and archival, let's put hot, cool, archival here. It also provides multiple redundancies as such. If you're aware of Azure, we have LRS, GRS, RAGRS, and so on and so forth, right? So 6 types of redundancies are there. And according to the redundancies, the data is replicated multiple times, either in the same data center or in the same region, or maybe across regions also, like geo copies are there. So now, if I start from somewhere here, so data lakes are amazing because we are able to store any amount of data over there. Now, even if you really think about a true implementation of data lake, then you would like to store all the data which you are collecting from various sources. And even if any for other system of the company goes down, it doesn't matter because we have all the data in the data lake. Now, if I take you back to my notebook and I just want to quickly go through the same thing again. So what is data lake? Data lakes are the cheap, durable storage solutions which all the clouds provide. In Azure, we have ADLS. They store all type of data. File format really doesn't matter. It stores any file format over there. You can also have data in open standards, Parquet file. It can be a Parquet file itself. Now, we have no limit in Azure Data Lake. You can keep any amount of data over there, petabytes as such. It provides enterprise grade security. We have file and folder level access concept. You can integrate Azure Active Directory with data lakes, and you will be able to give access to different team members based on the job profile in a sense, right? We can have RBAC over there. Everything is pay as you go. We are paying for the storage and we are paying for this transaction. It is highly scalable. It is, you can say, easy to manage. It's a PaaS solution as such. So one thing which data lake is doing is if I go back to the my main diagram, if you notice that if any company implements the real HDFS implementation in the cloud, then the thing which they will be stuck with will be the distributed machines on which the HDFS layer is, you can say, is deployed. So the company is literally paying for the virtual machines underlying. However, in this scenario where we have the ADLS in picture, here we are not paying for in any virtual machine at the backend. There is nothing like that. It's built on top of object storage and it is 100% compatible with the big data clusters. So big data clusters are unable to understand that they are reading from real HDFS or maybe from ADLS in a sense. So data lakes are amazing. They have very good features and so on and so forth. Now, the shortcomings of data lake will be that they are not ACID compliant. So there is not ACID compliant. Okay, that is one thing which comes to mind, and we have to see how can we overcome that, right? So not ACID compliant. Okay, one more thing. Now we have to understand the various type of data sources which the company are using or data stores which the companies are using, and then we will see where is Delta Lake coming into picture or where is Lakehouse architecture coming into the architecture. So if I just sip some water, just give me 1 second. Okay, now check this out. So the next thing which comes to mind is that all the companies have warehouses, right? We have the capability of having massive warehouses in Azure, in other clouds as well. So if I just move my diagram somewhere in the bottom of the page, something like this, and let's make one box over here. So what are the features of a warehouse? Any typical warehouse, which is, you can say any typical good warehouse will be having Mpp architecture. So if I just make a box over here, let me just represent the warehouse with this. So not a box, but if you can see that this is what I'm trying to create is an Mpp architecture. So what is the meaning of Mpp? Massive parallel processing. So what it does is the warehouses will be having multiple layers internally. So see, we have compute layers over here. Compute nodes are there, and then storage distributions are there like this. So any typical Mpp warehouse will be having this type of architecture, and control node will be there on the top. And whenever any query comes, so tables are distributed here. See, so this is where tables are distributed, and partitions will happen inside those distributions, and you can have indexing done on top of it. And if you're aware of column store indexing, that is there. And we also can have non-clustered indexing or clustered indexing, both type of indexing will be there. So it supports all these functionalities. So what are the features of any warehouse? Warehouse will be having Mpp architecture. One of the things which I want you to visualize is that whenever you run any query, the query will be in a map reduced manner, will be, you can say, will be broken and will be assigned to various compute nodes by the control node over there. Data will come from the storage node, something like this, and the query execution happens in these compute nodes over here. And once the query execution happens over there, the output is aggregated back and you get the output out, something like this, right? So what is the, if we just go back through the warehouse features, it is pretty scalable. It is having that Mpp architecture. It will be having caching functionalities on the nodes. And those, with the help of the caching functionality on the nodes, even the tables can be, or data can be cached in those nodes as well, right? Apart from that, now we also have capability of pausing the compute layer. We also have the capability of scaling it out, like scaling in, scaling out. So if you know about Azure dedicated SQL pool, which is a warehouse provided by Azure, they have 0 to 60 nodes over here, and the distributions are always 60. So what are warehouses? Let's go back to the notepad and have a look at that, right? So if I just summarize the benefits of warehouses again, then warehouses are something which are having massive parallel processing architecture. They can be paused whenever you are not using it, so compute layer is not there, and your data will be there in the storage nodes as such. Next time when you need it, you can start it. Works great. The It keeps relational data. It's a relational warehouse, so you must have heard about the various schemas which we have: star schema, snowflake schema, and any other uh, you can say warehouse modeling which you want to do, you can perform in this warehouse as such. So this is the same diagram which I have taken from Microsoft documentation of the Mpp architecture. Okay, so let's understand the challenges with both of them, data lakes and warehouses. And once we have understood the challenges, we will align, we will just find the answers for that with the help of Delta Lake and Lakehouse. We'll see how can we get best of the both the worlds, right? Let me just quickly check the question. Do we have API to connect to data lakes? Second, does ADLS has a private endpoint feature? Does it has to be, what is the mean to be ACID compliant? ACID compliant. Okay, so yeah, it has private endpoint feature. We have that features. Okay, now focus on this first. So challenges with the warehouse will be that they are amazing in relational database management, but they are not having support for video, audio, text as such. You can read data from the machine learning's point of view, but there is no, you can say, the number of connectors will be limited as such. Now, apart from that, there is no support for real-time streaming. If data is getting streamed, then writing in directly into the warehouse is not supported as such. What the other problems with warehouses are there, that the typical warehouse which you go for in from any of the vendor in the world will have some sort of proprietary mechanism where data will get logged in, right? So the customer may face some problems in connecting with other sources or moving your data smoothly from other sources. Now we know that in Microsoft Azure dedicated SQL pool, there are various methods provided to overcome these limitations of any typical warehouse in the world. So like polybase, and we have connectors, and we have other concepts. So keeping those things aside, the challenges with data lake will involve. So I have this slide deck over here for courtesy to Databricks. I will just quickly take you back to the first page. So the challenges which comes to when we implement data lake will be, they are not ACID compliant, hard to append data, modification of existing data is difficult, jobs can fail midway, and things can go inconsistent. When if you try to mix stream analytics with batch analytics on the data, it will lead to inconsistencies. The historical versioning of data is costly. The data grows in size. Metadata is also, or if you're having any true data lake implementation, then the metadata layer itself will be very huge. So you have to manage that too. The other limitations of data lakes will be that you may end up having too many files problem. You may have a lot of small files, and then these files are not optimized from the point of view of any big data cluster. So that's another problem. Then we have, because of this small files and because of partitioning of data, you may get some performance issues. And because you are storing, and because of all the reasons, you may also have quality issues, and your various versions of the file may not be having consistency as such. So the if I just take you back to my whiteboard, so we are able to understand that data lakes are having some of the features, right? Data lakes are having very good features. The warehouses are also having good features. So warehouse is also having, you can say, a lot of features as such. So the next thing which we are going to go with is how can we overcome the shortcoming which are there. Now, the first thing which happens with the first problem which happens with data lake is that it is not ACID compliant. Can we have the support of structured transactional? Can we have a layer on top of data lake which provides the ACID compliance, right? So that's one thing which comes to mind. So that's exactly what happens. So we'll just copy it over here. Okay, check this out. So at the bottom, we have the data lake. Data lake. And this data lake is implemented in Azure. So we'll just say this is ADLS Gen 2 over there. Now, on top of this data lake, there will be another layer. This layer is called as Delta Lake, right? So this is not a different storage location. It's not like it's another service which we are implementing. It's an open source layer which is implemented on top of ADLS itself. So this is Delta Lake over there. What this Delta Lake will do is it will provide the ACID compliance like that. So if I go and explain those things to you first, and then I will come and show the some other things which I have in the screen right now. So if I just skip a few of the graphics which I have over here, zoom in for everyone, the features of data, okay, the Delta Lake itself will be that it provides the ACID compliance. It is open source. You can have it's built on top of if you have any existing file with you, you can convert into the Delta file format pretty smoothly with just one command as such. And typically what customers do, they create multiple type of tables over there. So we create bronze tables, silver table, gold tables with Delta Lake. Now, what are these tables? It's not literally typically that there is something like a function called as bronze table. It's just like a theoretical concept that in the bronze table, we will keep the raw data. Now, this raw data might be coming as a stream. The raw data might be coming in batch mode. And Delta Lake will provide the consistency even in the scenario where from the same Delta location, both the stream job and batch job are running, then also the consistency will be maintained. And how do they maintain the consistency? They will have another transactional log. They will store the transactional log. We call it delta transactional logs as such. So with those transactional logs, ACID compliance will be provided. It's not magical. It doesn't mean that in case you are, if two people are modifying the same file or same observation, sorry, row over there or record as such, then it doesn't mean that both will go on, but you can say one of them may get an error to retry again, but the file will not get inconsistent. So three type of tables are typically what customers create: bronze tables, silver, gold tables, like where we have the raw ingestion of data. In the silver table, we are storing the filtered, clean, augmented data, and in the gold table, the aggregates are stored on top of which the BI can be performed. So if I just take you back to my diagram, and if I just maybe I should have made it slightly bigger. So let's slightly make it slightly bigger over here. Okay, so what is this Delta Lake providing us? Something like this, right? So if I create, so what you will see me is that in next few minutes, I will be creating few tables over there in Delta Lake. So when we'll create those tables, something like this will happen. So we will create one table here like this, and the data is persisted in the ADLS only, right? So we have to create ADLS before it, and we will mount it inside the cluster, Spark cluster over there. So what will happen is, if I create the table something like that, then inside the data lake, what will happen here? A few folders will get created. We will create them. You will see that we are creating something. So I'll just zoom in first, right over here. So this is basically, we'll have delta logs will be there. Delta logs. We will also have checkpoints, and then Parquet file will be there. So I'll just say file.parquet like this. So the data at the backend goes inside the data lake itself, which is the durable, cheap, and pretty versatile type of storage location with no limit and so on and so forth, right? All those things still hold. But this is going to happen on top of the uh, data lake. Now, if I just show you a couple of more things. Now, let's find the main diagram which we were trying to make. Now, apart from this, there is another architecture which you should be aware of. We'll create those tables in few minutes, but I'll just want to take you into another direction at this point in time. So typically there is another architecture which the world is right now going towards, which combines the best of the both worlds. Like we have the best of the data lake, and we also will have the best of the warehouse. But right now the companies are having the two-tier data architecture, where the companies implement the data lake, and then a subset of the data is moved inside the warehouse over there. And this subset of the data which is moved will be moved with the help of any ETL job. So the ETL job itself will create some sort of latency, delay, complexity, may also fail. You have to take care of that as well. So all of those things happen. So if you, right now the companies are keeping the data in two different tiers. So they have to pay, you can say, twice for the data which is being stored, once in data lake and then a subset of that in the warehouse. So from the data lake, they are providing capabilities to, you can say, machine learning capabilities are provided when you read data from data lake. And from the warehouse, we have the reporting and the BI capabilities. So warehouses are amazing in that. Now, this is where there is another architecture which is coming up, which is called as Lakehouse architecture. It's not coming up, it's already there. Right, a lot of implementation is going on. So where the Lakehouse architecture comes into picture, which combines both data lake with the warehouses. Now in Lakehouse, there are typical uh, you can say features of Lakehouse as such, where the Lakehouse is eliminating the two-tier architecture used by the MNCs right now, and the Lakehouse uh, will be working uh, or will be built on top of the open formats like Parquet. Lakehouse will be providing world-class support for data science, machine learning, as well as reporting from the same location. So you don't have to keep your data in a data lake and then in a warehouse separately. You will be able to combine both of them and unify both of them into another Lakehouse architecture. So Databricks brings up this Lakehouse, and the implementation of Lakehouse from Databricks, basically, I'll just move this box on top of this. Okay. Now, so if we have to implement the Lakehouse architecture, which is unifying both the data lake and delta lake together, sorry, data lake and the warehouses together into one unified approach, then according to Databricks, there is another component in this architecture which is sitting somewhere over here, like this, over here. So this component is the Delta engine, like this. This Delta engine is available inside the Databricks clusters, or you can say Databricks workspaces. So you can deploy Databricks workspace in any of the clouds, right, including Azure. So if I just make this solution like that, I just want to walk you through the notebook which I created, and I'll just take you back to the to a few of the graphics which I had. So there was a white paper which came out. You can just look up in any of the search browser for this white paper. And this white paper is the one where Lakehouse was introduced. And it's the new generation platform where the unification happens of the data lake and the warehouses, and it's an open field. It's not you can say totally you can say there is no, it's not that it's not having any shortcomings, but it's a field where research is going on right now, right? So there are three typical things which are there in the you can just look up for in the search browser. I'll just do one thing. I have the summary of it. I'll scroll down. I'll show the summary of that. Okay, so the features of the Lakehouse architecture will be, it should support the variety of data types and formats. Reliability and consistency should be built in. Should be having the world-class support for BI, data science, machine learning, and analytics. Should be the BI tool should be able to directly read data from the source itself. The two-tier data architecture, which is very prevalent in the industry, is being eliminated by Lakehouse as such. So we don't have to pay double the cost and all that. And ETL, the complexity introduced by the ETL jobs moving data from the data lake to the warehouse will also be reduced or eliminated, not really eliminated, but reduced in the practical implementation. Now, uh, so the this is the you can say I have this graphics from Databricks. Basically, if I can zoom out, I can show this to you completely. Okay, so this is how that looks like. It is having the analytical, real-time, and data science, machine learning requirements, and so you can keep structured, semi-structured, unstructured data. So it is not having that limitation where warehouse cannot unable to provide the support for audio files or video files as such. Now, the implementation of this basically is what we were just discussing, that there should be a metadata caching and indexing layer on top of it, and then we will have some SQL APIs, or will have some APIs to from the point of view of data frames. And this is what I was creating before for you. That on the bottom, if you see over here where I'm moving the cursor, this is the data lakes ADLS, and then on top of it, we will have the Delta Lake, which is the structured transactional layer built on top. And then on top of that, we will have the Delta engine, which will provide the uh, high performance query engine as such. Now, the Delta Lake is one of the component which is providing the asset compliance, right? The other component which is over there is called as Delta Engine, this one. So this is the high level architecture of how the Delta Engine looks like. It is having SSD based caching. It is having a Photon native execution engine from Databricks, and query optimization will be done on top of it. So if I just quickly click on the compute and I say create a new cluster, the Photon can be enabled from here like this, right? Like that. Now, if I take you back, okay, and then once we implement the solution in Azure, it's going to look something like this. We will have, if you know this is Event Hub, IoT Hub, Data Factory. So these are the stream ingestion solutions. Now we don't have to we don't have to create the Lambda architecture where the stream is getting maintained, is separated from the batch layer. The same tables are now capable of having of providing the of running streaming queries at the same time. The batch queries can execute on top of it at the same time. That's what we will see in the scenario as well. So even if you are getting data from Event Hub or IoT Hub as such, or you are ingesting some data from Data Factory from on-premise, there are multiple mechanisms by which we can ingest data. And these are those type of tables over here, the bronze, silver, and the gold tables, where the data is being kept in the raw format, and then in the silver tables we are having the data in the you can say refined data is there, and the gold tables are the ones where we are creating the aggregations on the data. The BI or reporting ready data is the third one, the gold data. So sorry, I'll just sip some water. Give me a second. So I'm recovering from COVID, so my voice is little it's not really what it used to be. Now, anyways, so okay, now the same thing which we discussed, that there will be multiple checkpoints and so on and so forth. So I have this scenario with me over here. I'll just explain the scenario to you, and check this out. So in this demo which is set up over here, there is a data source. So this data source is another storage account where we need the data for showing the demo, right? So I have this data source. It's just for the demo setup. Now, this data source is basically having 5,000 JSON files over there. So this is how I'm representing those JSON files. Now, what we are doing is we have basically we will be creating one stream source over here. First, we'll make the streaming source, and then we will do the batch ingestion of data. Both we will see how that can be done. So basically, we'll have the stream of the data coming from there, and we are going to create three different delta locations. And based on those three different delta locations, three tables will be there: bronze, silver, and gold. Bronze table is literally called as bronze table. I named it the way it is. Silver is just like that, and the gold one is having out a name called as grouped count, like this. So the data is coming in this bronze table first one, like this. Now, once we have the data in the bronze table, we are going to enrich the data. So I have another uh, source from where we will be getting more. We'll make one data frame, and this data frame will be having some data. We'll get it something like that from there, and whatever data is there in the bronze table, we will enrich the data we'll join the data with the other data frame, and we will create the silver tables, right, like this. And we'll see what are the various columns which are added in the silver tables. And once we have done that, we will be running one aggregate function, and this will be creating the gold tables on top of it. So something like this, right? And we will create some basic dashboard on top of it. We'll see how it will look like, something like this. So this is what I'm going to show you. And the one thing which I skipped in all of this is because today's session is for someone who is getting started with this concept which we are discussing. So I will also show you how to mount the ADLS inside the Databricks using service principal, right? So typically at the backend, everything will be in ADLS, something like this. So this should be the first step, right? This is the first step actually, and let's do it. Something like this. So whatever we are doing, we will be able to see those files getting created in the ADLS location. Now I'll just take you back to the uh, Azure, and let's do it. Okay. Now I am just going to take you back and let me show you what I have set up for you. And I have this resource group with me, Reactor RG. And in this Reactor RG, I have some of the resources. I basically have one warehouse just to show you. If we get time, I'll just show you the warehouse as well. This is the ADLS, and this is Databricks. That's one key vault which I have. And that's the signups, not really required right now. It's just there. Now, typically, how do you make how do you mount anything? Like, how do you get your data? How do you make sure, how do you define the external source inside Databricks? How do you do that? So the very first thing we have to do is you go to the Active Directory, and in Azure AD, we have app registration. Make your app registration. So this app registration will, which you can see, I have this named as ADLS Access Service Principal. So what this app registration will do is it will create this service principal, and I will just copy the details from it. The application ID, this is the directory ID from here, and in the secrets, I have created one secret over here. And once you have this, to be able to ensure that you don't hard code anything anywhere, the next thing is create one key vault. Now inside the key, so this is how we do it in production, right? There will be more layers of, I have the rights right now, so it's working very smoothly. But in your practical environment, when different teams, when you will not have the rights, you have to request the identity team or the AD team in your company to create those service principal and the rights, allocate the rights and all that. So you can think it through. But basically, this is my key vault, and in the secrets, I have created one secret where it should load here. Okay, this one. So what this secret is having is basically it is having the key of the service principal. Now I apart from this, I have already I will just go to my data lake, So this is data lake. You basically have to click on it, access control, add role assignment, and you assign the role which typically will be storage blob data contributor. So I'll sip some water. Just give me 1 second. Okay, now, so if I can just slightly zoom out so all of you can see it properly, we have associated the storage blob data contributor right to the service principal over there. Now, things are done. And then the next step is basically go to the, you come back to the Databricks, you create a secret scope, right? And then you go to your notebook. And then if I just zoom in for you, it's a typical boilerplate code over here for doing the mount of ADLS into the Databricks cluster right now, in the DBFS right now. So we have provided the client ID of service principal over there. This is the secret scope name. That's the name of the key in AD in the key vault. And this is my directory ID for this demo. This is Azure AD's ID. And then this is my data lake, which I'm using over here. And I have mounted this as data, so I don't have to I don't have to directly read from the ADLS directly. That doesn't, instead of that, I can mount it. And then based on the access, people can read right from it. So if we check it out, the mounts are done. So this is the mount from which we are going to use as such. This is the data lake. The data is one of the file system which I have created inside my data lake. So I'm not sure if you have already seen it or not. Let me just quickly show you how data lakes looks like, right? So this is the data lake over here. And we have container, file share, queues, and table services over there. But the typical service of which is the equivalent to HDFS is the first one, container. Now, if I click on it, uh, this is the file system which is what we are connecting to from Databricks. Now, okay, and this is the one where I have the training data. This is for my demos setup. I needed some data, so that's the location, which in the diagram is this location, this box over there. Right. Okay. Now, this is what I was telling you about, that we need to have, so that when you will create the delta tables, they will store the transactional logs, and when you create the streaming in the streaming scenarios, you also need the checkpoints. So if I'm let's say I want to move data in incremental manner, then I need to have some checkpoint, and tomorrow from that checkpoint onwards, your data can be moved and so on and so forth. So these are the path which we are providing over here, where the data will be kept inside the ADLS. So if we just go through it, we have three paths as such: bronze. There is a checkpoint of the bronze, silver, checkpoint of the silver, gold, and the checkpoint of the gold as well. Now, where is this? If we go to ADLS and click on the data, and this is actually the name of one of my folders over there. So if I'll just move it over here like this. So this is actually the activity path. I'm getting the activity path one directory over here, and inside that, these are the three paths which will get finally created, and we'll have the data inside that. So if I just take you back, so once we define the path, the next thing which comes to mind is like, what is the data, or what is the scenario which we are doing right now? We are getting the data from the cell phone. There is an accelerometer in the cell phone, and that is streaming all the data. You can think in terms of Fitbit band or any Apple Watch or any other device which is streaming the data from the various, you can say, athletes, or maybe anyone can have them. So the data will be having attributes like index, arrival time, creation, XYZ coordinates, user, model, device. What is the customer doing right now? Standing, walking, climbing the staircase, and so on and so forth. So based on this data, you will be able to do a lot of analytics on top of it. You can even find the health of the customer. You can also find whether the person is, what is the, you can say, how much calorie is the runner burning right now during the run, or how many steps have you walked, and all of that. So geographic location as well. Now, so we are defining the data first, and the attributes are defined over here. I have the schema over here, arrival time, creation, and so on and so forth. And basically, once we have defined that schema, as I was saying that there are 5,000 records, there are 36 files in my setup location, in this location, and each file is having 5,000 records as such inside it. So we are creating one, we are doing spark.read stream format JSON. JSON is the file format over there. And max file per trigger, like in micro batches you read, how many files are you going to consume during the load operation. And from where am I reading? This is my setup, data setup location from where we are reading the stream as such. Now, there can be a lot of other scenarios where you have Event Hub, IoT Hub integration, and those are the solutions which are streaming the data. Okay, now, so this is just like a data raw event data frame where we have started the stream. So if I just take you back to my diagram, this is this arrow, this line over here. That's what it is representing, just to show you how the ingestion will work. And if I just take you to the next one, so how do you make a delta table? Like what's the syntax of it? So it's a very simple syntax like this. So I have my data frame dot write stream format delta checkpoint path, and the what type of mode are you doing? Are you appending the file, which we will be doing, or are you going to override the full file? Like if you do any aggregation, let's say today, and tomorrow you got more data, and you want to modify the aggregated data, basically you are doing an update statement as such. So in that scenario, you would like to calculate the entire aggregate, let's say the average of the column one more time and overwrite it. So complete mode will be there. And then where do we write the location? So this is the delta location. So delta location path will be ADLS as such, which we have mounted in the previous step. Now, okay, so the stream is still running. I just executed it before the session, but seems to be still going on. Okay, so this is the activity bronze path, and that's the data which is getting ingested into the bronze table in the first one over here, this one. Now, where is this location, right? If I just take you back to my data lake, I click on bronze, you will literally see the folders which we have created. The delta logs are there, checkpoints, and the Parquet files. These Parquet files are the ones which are having data. I have not partitioned further. You can further do partitions as well on top of it. And if I just, I have created one table on top of it, on top of the delta location, which is there, the bronze delta location. And once I make this table, I can also manage the table from the data section over here. So this is my default database, and that's the table which is showing over there. And if I just, we can run statements like that. And this is the data which we are getting, arrival time, creation time. This is my raw data. So devices, index, model, user, geographical location. The user is standing right now. The user is having a lot of records of standing, and others will be there walking and all that. Now ID, the coordinates XYZ, like this. So then I am enriching my data over here. So what I'm doing is basically I'm getting the data from another source, and this source is having the country code, the country names itself, country code, and some other information which I am getting from another source. And we will be reading the data from the bronze, and we will join with the other data frame, and the output we will write in another table, which we are calling as silver table, where we have another, you can say, refined data. So this is that location. This is another location. This is a data frame, geo for lookup data frame, and we are reading the Parquet file. It's in the setup location where country codes are there. So we are getting the country codes from there, and then we are going to join. We are doing one join operation, and then we will write the data in the query in the silver table, which we also can call as query tables because you can run queries on top of it. So if you notice over here, this is my data frame past event data frame, and the stream is coming from the delta location, which is the bronze table over here. That's the path I have defined on the top. And then we are running one select statement on top of the data in the bronze table. And then we are doing the join with the geographic lookup data frame, the lookup table, which is having the country codes and so on and so forth. Now this parsed event data frame, that's what we are writing into the silver path over there. So the next path as such, same format. The syntax is not really very difficult. Write stream format delta checkpoint at the backend output append location. Now I have also created one silver table on top of it using the same location. So create table silver using delta location and then specify the delta location path. And this location path is the ADLS folder. So if I just take you back to that and go one page back, you see this directory over here, this silver, that's where we are pointing. And it's pretty symmetrical. The logs are there, asset company, the checkpoints are there, and the Parquet files are there. So you must have already, I may have already told, or maybe you already got it, that the backend is Parquet as such, right? The file is stored in the Parquet format. Now, if I just take you back, this is after we were able to do the join operation. We have the countries as well, and the three new columns should be there: country, and basically the city and the country code, like this. So this information is how we have refined that data with. So now I already manually showed you, but you can also list out all the files which are there in your in the delta location inside your ADLS. So this is where we have done that, and there are two streams which are going on. Okay, now the third type of tables which we generally create with the help of Delta Lake will be the gold aggregated tables. On top of it, we can have Power BI reports created, or we can have dashboards, or we can embed other locations and read data from. So this is that. So basically, the third table name which we are creating is called as grouped count. We are grouping the counts and we are doing the aggregations on top of it. So how do we do this? We are reading the stream. So right now the previous stream is still running, right? So data is coming from if data is there. So I just want you to remember. So let's say data was coming into this location. Then the data is also continuously going inside the bronze table. Silver table stream is also right now running. It is not stopped. So if the data was coming from there, then joins are going on, and this is also where the append of data is going on. And then on top of it, we are working with we are aggregating the data in real time. So it's not a batch mode which we are seeing right now. We are seeing this in stream mode. So this is the hot path of the Lambda architecture, which we are seeing as such. Now, okay, so after the grouping, we are writing this over there in the grouped count table, which is the bronze table name which we gave. So this is how it looks like. Finally, this is the bronze table, which is named as grouped count. So we have the ground truth over here, like uh, the you can say standing, sitting, walking, jumping, and all that, right? Country codes count is there. So then I want to show you one more thing, is that one of the very interesting thing is that it is very easy to maintain the history. Now, if I just run something like describe history of the grouped count, it will show me with timestamp that what operation was done on top of it. We didn't delete anything, but it was the update operation happened on top of it. But if let's say some delete operation happened, it will show over here. Now you want to recover, or you want to load the data which is before the delete happened, then you can just run the query with the help of the timestamp which was before it, and then you can see what happened, who ran the query, and what data was deleted. All those things can be audited with the help of the history which is there. Pretty interesting thing. Now, uh, this is where I have one view which is created on top of it. So that's over there. Now, in this point in time, when the stream is going on, we are also running one batch query on the same table. So it is, and just what we want to remember is that the Delta tables are able to run the stream and the batch queries at the same point in time consistently. So in this example, we are doing a simple spark.read format JSON. Schema was defined on the top. This is the setup location of the demo, and we are writing the output in the bronze path. So this is the batch job. So it's not in this screen right now over here, but I can say that this is, you can say this is where the batch data was getting ingested into, like that. So this is the stream one. Streams are coming, and this is the batch ingestion going on, like this. Okay, now, and we were able to load some millions of data. Okay, now then on top of it, so the tables are still, so this is the final grouped count table after both the batch and the stream job on top of it. So then we can also stop the streams, otherwise they are running right now. So I'll just go back and I'll summarize this for you. So there are three things which we have talked about today: the data lakes, the delta lakes, and the entire concept of the lakehouse, where we will be able to combine the two-tier architecture into one tier itself with the help of Azure Databricks, with the help of Delta Engine plus data lakes, which will provide the asset compliance. Now, I will just take your questions as such. And this is what I had for the demo. If you have any questions, feel free to ask. And let me just read a few of the questions. Okay, under data lake, is there any ETL tool which converts input data to curated data? If yes, won't the ETL tool add complexity? Okay, we have ETL capabilities in the Delta. They are called as Delta Live tables. The Delta Live tables are in a, you can say, in a private preview right now. So I don't have access to it. Otherwise, I would have shown you how to create the ETL with the Delta tables. And yeah, it will add definitely if you have another job, but you can say it will add less complexity versus using another product and then paying for that product over there. And here we have everything inside the same lakehouse where you are having your ETL jobs running, right? Okay, so can we get access to this notebook URL? Yeah, the notebook URL will be there in GitHub, and we will put that GitHub location uh, in all the locations from where you can find it. You can also find me on LinkedIn, and you can I'll post the GitHub URL. Okay, so there is another question. What happens to the entire process if there is a change in the data schema you showed in the first step? Okay, for example, I'll get the error. Error will come. Let's say later on you are getting, you can say if you have different number of columns, you will start getting errors. Is Delta Lake feature free? Oh, yeah, correct. Delta Lake is open source. It is free. So it was created by Databricks, and they open sourced it many years back, and it's being adopted by all the clouds. Is the session recorded? Yeah, session will be there inside YouTube Reactor link. Okay, will the Lakehouse be prepared to handle with cubes and metric calculation the main role of data warehouse? Now there are a lot of things which are not yet supported. The last which I checked, the relation the foreign key relationships are yet not supported. So things are under, you can say, are going on right now, and the support for more functionalities will come on the way. A lot of things may not be there today. Do we need to define a schema in both live and batch? In live, you have to define it. In the batch, it can also infer from the source. What's a checkpoint? And for every new JSON file, how Lakehouse knows? Checkpoint is, for example, let's say, okay, so when my job will finish, all the 5,000 or 36 files into 5,000 records will load inside the bronze table. Then if I get more data into that, with the help of the checkpoint, it will understand that from where what was copied last time and what we have to do now, so that incremental, it's state, basically it's state. So state is maintained over there. Okay. So Lakehouse supports only Parquet file format if we get in data in other file formats. Okay, Lakehouse, sorry, the Delta concept, the Delta Lake store the data in Parquet file format. It doesn't mean I cannot load CSV or any other file format. We have all the capabilities of loading all the file formats. The storage file format is Parquet. So the next question is, for developer access to data lake, do we have to access API endpoints with RBAC? You will be having RBAC is so Azure Active Directory based RBAC is the standard way of working in Azure platform. Apart from that, there are other ways as well. We have managed identities. That's also pretty standard. And you can also use the key-based concepts, but that doesn't control the or shared access signature as well can be used. So there are many various methods. RBAC are on the top of how the things are implemented. What if we get duplicate data? The duplicate it will take care of it. The conversion from different file format to Parquet will be managed by Delta Lake automatically. No, we will define it. For example, I will say that this is my Parquet file. Now convert to Delta, and then it's a smooth conversion. Or you have a CSV file, you have it inside ADLS right now, you can convert it into Delta. Do we need to mount the data lake files every time or only once? It's a one-time operation. You don't mount it every time. Someone in the team with high level of access will do it, and others will just use it. Okay, so okay, right. What is the difference? Duplicate data will be taken care of. Duplicate data will be, for example, if you are getting a stream, if you are maintaining the checkpoints, it will understand that what is the state is being maintained. Can you explain the blob and data lake once again? Blobs are in storage account. We have it's built on top of object storage. Blobs are there, and the ADLS concept is also built on top of object storage itself. It is having the file, you can say file hierarchical functionalities on top of the object storage. So ADLS is built on top of the same object storage, which is the storage account. The differences will be in terms of the metadata rewrite operations, which are there in ADLS, which storage account will not support. ADLS has no limit. It has the file and folder level uh, functionality where you can give access, and blob storage doesn't have it. ADLS will provide more throughput. ADLS is also expensive versus storage account. All of these things are there. Okay, so now what's the next thing, guys? Right, you will get the link of the notebook. Please find me on the social media platforms and follow us over there. Now, those who want to perform whatever we have done and want to further learn more, I'm putting the link in the chat window, right? That is the link where the what we have discussed is hosted in MS Learn, and you can access that from that link over there. And you can simply go and read further. There are further paths which are there. You can even go and explore those paths. If you are looking for Azure subscription, free trials are available. Go for it, deploy it, and join us for the next sessions as well. Okay, any other question? Please go ahead and ask your questions. We are dot on time. Okay, So, Rashmita, if there is any other thing which we need to take care of, then let me know. Yeah, okay.
Sure, I don't see any questions. So, yeah, I think we can wrap up the session. Thank you, Shivam, so much for this amazing session. And thank you all for joining us today. Please feel free to share your feedback about today's session. And also, as Shivam mentioned, please feel free to use the Learn module link, which is given in the chat section. This will give you access to additional resources to take your learning further. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. Thank you all once again and enjoy the rest of your day.